Okay, last videos, and this video will be all about examples. So taking a look at our lesson 12 packet, I'm going to go over exercise number 3, at least a few examples from there. So let me go over example letter A. So example letter A is asking us to find the inverse sine of root 3 over 2. And don't forget, this is an inverse sine. So that means we're used to our normal sine functions where we take in an angle and what we get back out is the height. And our inverse sine function, the question now is, given a height, what is the angle? So the input and outputs are switched. So this question right here is, my height is at root 3 over 2. What is the angle that gives me that height? So drawing out on a unit circle, here's my unit circle. Root 3 over 2, it is positive, so it has to be on top here. We know that root 3 over 2 is actually relatively close to 1, so it is here or here. Here or here. And if you go ahead and draw out your special right triangles, or based on your knowledge of the unit circle, you will know that this angle here has a reference angle needs to be 60 degrees. Our reference angle here needs to be 60 degrees for our height to be at root 3 over 2. Root 3 over 2. So how much have I rotated such that my reference angles here are 60 degrees and 60 degrees? Well, here this is 60. This one is actually 180 minus 60, which gives me 120 degrees. So at 120 degrees and at 60 degrees, my sine value is root 3 over 2. So that means sine of 60 degrees is root 3 over 2. Sine of 120 is equal to root 3 over 2. So, given this information, my inverse root 3 over 2 is either equal to 60 or 120. Which one do you choose? You can only choose one. So go back, look at your domain for your sine and cosine, and you'll notice that the domain restriction that we've chosen for our sine function is from negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. And this is the domain for our sine function, which happens to be the range for our inverse sine function. So our range is the exact same thing. Range is what we get back out. So that means the angle that we get back out needs to be in between negative 90 to 90 degrees. Which one is it? Well, not 120, so it's got to be 60. So that means the inverse of root 3 over 2, the inverse sine of root 3 over 2 is equal to 60 degrees, or pi over 3. Okay, so taking a look at our question here, it says, do it without a calculator. We've done that because we know our special right triangles and our unit circle, and use radian measures. So we also don't want 60, we just want that pi over 3. Okay, so that is example number 3. Let me go ahead and pull over to example number 2, because this is where things are actually helpful. So solve a trigonometric equation such that our x value is between 0 to 2 pi, so they've restricted part of the domain for us, and then round your answer to 3 decimal places. So let me write this down. So 2 cosine of x minus 1 is equal to 0. And this is example number 2. And what I want you to know is, for example number 2 and a few of the practice problems, sometimes they'll ask you for exact form, in which case you have to do it by hand without a calculator so you can get your radical answers. Now if it asks you to round it, just go ahead and use a calculator. So here's example number 2 using a calculator, and I'll go ahead and solve it by hand. So how do you solve it with a calculator? Well, we're solving for x, therefore isolate your x. How do we isolate our x? I'm going to add 1 on both sides, and I get 2 cosine of x is equal to 1. Trying to isolate my cosine here, so I'm going to divide both sides by 2, and I get cosine of x is equal to 1/2. Great, cosine of x is equal to 1/2. Now I can go ahead and start guessing, or not guessing, but checking my unit circle. So where is cosine of 1/2? Where is cosine of an angle equal to 1/2? Notice that it's at, I believe we went over this example, it's at 60 degrees and at 320 degrees. Okay, So which one do we want? In this case, we want to be careful because it could be both. But what is our convention? Our convention for our inverse cosine. So let me go ahead and rewrite this in my inverse notation. So my inverse notation is x, because that's my angle. My angle is equal to the inverse function of the actual height, or co-height value in this case, 1/2. And my x value, my angle, is equal to 60 or 320. And looking back at my convention for cosine, my cosine's range is from 0 to 180. So which of these two values do we want? We don't want the 320, we want the 60 degrees. So x is equal to cosine inverse of 1/2 is equal to 60 degrees. So that's how I do it by hand. Let me go ahead and pull out my calculator now. So here's my calculator. Right now my calculator is in degree mode, and what you will notice is we can't plug in cosine of an unknown value, but what we can plug in is cosine inverse of 1/2 to get our value of x. And that's the power of rewriting things in inverse function notation. So now I can write my angle is equal to inverse cosine of 1/2. So let me go ahead and find cosine. Here's my cosine function. And just like our log function, the inverse function is just the shift mode of that. So here's my cosine. My inverse cosine is right on top of it, that cosine inverse. So I'm going to click shift, cosine inverse, there you go. I'm going to put parentheses around that and do 1/2. Okay. So when I press enter, I get 60 degrees. Awesome. So there's some instruction on how to use your calculator to find the angle. So let me go ahead and just put 60 degrees. That is my answer. And that is example number 2.